In the last video, we saw how to analytically tell that which line is steeper than the other line. We devised a method for that called the slope. We also saw that the slope of a line is always constant throughout, which means that the rate of climb to walk is always constant. Now in this video, we are going to talk about the slope of a curve. But think about that. Does the slope of a curve even make sense? Well, if I give you 2 points, P and Q, okay, and if I ask you to find out the slope between this point P and Q, then you will say that if I walk this much, let's say x unit, then I climb y units. But if you take another point R and S, for the same amount of walk you will be climbing a lot. So your slope between R and S is going to be much higher than your slope between P and Q. So we can say that the slope at each and every point in this particular graph is actually changing. So we cannot associate one particular slope of a given curve, right? So how Leibniz thought about this is that he imagined this whole curve to be made of infinitesimally small lines. He said that, hey, I can picturize this whole curve to be made of very small, infinitesimally small lines, right? And when you say that please find the slope at this particular point of the curve, what I'm going to do is I'm going to find the slope of this small line. That will be very close enough to the slope of the curve at that particular point, right? So how we can see about this is that you can extend this infinitesimally small line in both directions, and this will be your tangent to the curve at this particular point. Okay, so finding this slope of this particular tangent will give you the slope to this curve at this particular point, and that's easy, right? That's the whole solution, in fact. So you can do what? You can just find out the angle that it makes with the x-axis, and then you find the tan of that angle, and this will be equal to your slope. Simple, right? But wait, let's try to do this analytically. Okay, let's go back to our same steps. What were those? Let's take 2 points and then find out delta y by delta x. But wait, here I'm not given 2 points, right? I'm just given one particular point and I've been asked to find the slope at that particular point. So what about the second point? So let's think about another method. So what we're going to do is, let's have our axis, let's have our graph, okay, and we have been told to find out the slope at this particular point, x naught, y naught. Okay, so let's take any random point x1, y1, and let's try to find out the slope between these 2 points. So you are going to walk from x0 to x1 until you reach vertically below it, and then you're gonna walk up to it, right? This will be your delta y, this will be your delta x. Your delta y will be y1 minus y0, delta x will be x1 minus x0. Okay, and your slope is going to be delta y by delta x. This will be your slope, right? But this is the slope of which line? This is the slope of the line joining these points, right? This particular line. But what are we interested in right now? We want the slope at this point x0, y0 on this curve, which is going to be the tangent. This, right? So you'll say that, hey, your slope is not the slope that I'm interested in. We have a clever method to actually find out the slope of this particular tangent. What we're going to do is, we are going to bring this point closer to your first point, x0, y0. And then we're going to find the slope of this new point with x0, y0. So what is that going to be? That is going to be the slope of the line joining these 2 points now. Hey, the slope that I'm going to give you is getting closer to the slope of the tangent, right? Correct? So now what I'm going to say is, I'm going to say let's bring this second point very close to the first point actually, such that the second point is not on top of the first point, but it's very close to the first point, so that the secant, right, the slope of the secant is very close to the slope of the tangent at that point. And that's how we define tangents, by the way, which you'll learn in your maths classes. Okay, so let's do that. Let's just zoom into this whole picture. Let's have our axis. Okay, and let's take an actual curve. y is equal to x square, or fx is equal to x square. Fine. So you all know about that, right? How this curve is going to look like, something like this. And let's say you have to find out the slope at point x0 y0. Okay, and I'm gonna take another point that is, well, it is very close to x0 y0, but just for the sake of making it more visual, I'm just gonna show it at a distance. Okay, so this point is very close to x0 y0. Let's say the x coordinate of this particular point is x0 plus some small delta x. Okay, so what will be the y coordinate of this? By the way, let's come over here. x0 and y0 is our point, right? What will be y0, by the way? According to the graph, according to the equation, y is equal to x square. So this point has to be x0 comma x0 whole square. Correct? Now this point over here is going to be x0 plus delta x. How far is this? This is delta x far. Delta x meaning some small distance, right? And what will be the y coordinate? Well, we have been given the curve, right? So we know the y coordinate will be x0 plus delta x the whole square, and this will be our coordinates. Correct? So let's go about our method of finding slope. So the slope is going to be delta y. Okay, so delta y is this minus this, okay, which is this, right? So this is going to be x0 plus delta x the whole square minus x0 the whole square, divided by delta x, which is going to be x0 plus delta x minus your x0. All we need to solve this is simple arithmetic. So slope is equal to x0 square plus delta x square plus 2 x0 delta x minus x0 square divided by, well, this is going to be cancelled, right? x0 minus x0, and we'll end up with delta x, right? And similarly over here, x0 square cancels x0 minus x0 square. What we're left with is delta x whole square plus 2 x0 delta x by delta x. But wait, if I have to solve this, if I need to find the slope at this particular point, I need to find the tangent, the slope of the tangent, right? That's what we talked about. Now for the tangent, the second point has to be exactly above the first point, right? Then only it is a tangent, because that tangent is going to touch at just one single point. Correct? So in that particular case, your delta x will be equal to 0. But wait, if delta x is equal to 0 and I substitute that in my slope equation over here, what I'm going to get is this term will become 0, and this term will become 0, and this term will become 0. So I'll get something of the form 0 by 0. I don't even know what that means. How I'm going to find that? So here's the genius, by the way. What we do over here is we introduce something called as limits. I'm going to say that delta x is not equal to 0, but delta x is limiting to 0 or tending to 0. Delta x is tending to 0. Okay, so this delta x is not 0, but very close to 0, like 0.000001 maybe, you can say that. Fine, but not actually 0. In that particular case, you can do the calculations. Delta x square plus 2 x0 delta x by delta x. Fine. So given our assumption that limit delta x tends to 0 but not equal to 0, what we'll get is we can just cancel out delta x and delta x from here. What will we be left with is delta x plus 2 x0. Okay. Now let's say x0 is some point. Let's say this x0 was some point 2 comma, what will be your y coordinate? Y will be 4, right? Since the equation is y is equal to x square. So let's say your x0 is 2. So in that case, what do we decide? The delta x is tending to 0, the delta x is very close to 0. So what this whole term will become is 2x0, because delta x will be very small to 2x0, right? So I can just neglect that whole term, and this is going to be my slope. Slope of y is equal to x square at x0, right? You can just substitute the value of x0, which by the way is 2, and then you will get your slope to be equal to 4. This means that this particular tangent over here, okay, this particular tangent over here at 2 comma 4, okay, that has a slope of 4. That means the angle that it makes with the x-axis, okay, positive x-axis, the tan of that angle will be equal to 4. It's another way of finding the slope. So in this video, we figured out that slope of a curve is a meaningless statement. We can only find out the slope of a curve at a given point, and we found out how to do that with the help of something called as limits. And now you are in a position to calculate the slope of any given curve using the same method that we talked about. So let's do a problem. Let's do a homework problem. Why don't you try this out? Given curve y is equal to 1 by x, find the slope of it at x0, y0. So this is your problem statement. Try doing that at your home.